Okay, before getting to looking at the graphical solution, let's talk a second about preferences. Sometimes with this intertemporal choice model, instead of looking at just indifference curves, we imagine preferences are generated by a flow utility function U and a personal rate of time preference parameter R. So utility of the bundle is given by U of C0 plus U of C1 divided by 1 plus R. That is, we discount future utility just like you discount with the interest rate, but R is a personal preference parameter. In particular, this implies that when the bundles are the same, that is, when C0 equals C1, the marginal rate of substitution for the consumer is 1 plus R, and then you can relate this rate of time preference parameter as a measure of consumer impatience, which means even if income is flat, I0 and I1 are the same, the consumer will be a borrower if R is greater than the market interest rate I, and a saver if R is less than I. Okay, let's look at the graph now. You have several controls here. You can set current income, which at the moment is set at 0, and future income, which is set at 900. That gives this blue diamond point here. You can set the current market interest rate. You can set this time preference parameter, what we just mentioned, and we're going to do comparative statics with respect to the interest rate, so that's what this control is for. So let's start doing that. I'm going to raise the market interest rate that the person currently faces, and look what happens. So let's figure this out. Okay, so we raised it quite a bit so that we can make the picture dramatic. This $439 of consumption in period 0 is financed entirely by borrowing because the person has no current income. When you raise the interest rate, this borrower is experiencing an increase in the price of current consumption. The substitution effect for that is moving to here. Both goods are normal in this case. The income effect is moving to here, and so after the increase in the interest rate, less current consumption without any question because the person is a borrower. Okay, so now we're going to look at a new case where the consumer has only current income. $940 is current income. There's no future income. At the current setup, 940 minus 481 is how much is being saved for the future, and that allows this consumption in the second period. And now we're going to increase the interest rate again. This consumer is a saver, so let's raise that interest rate and see what the new budget line looks like. Now notice that this intercept is staying fixed. What's happening now is it's as if future consumption is getting cheaper. This represents the choice after the interest rate has gone up. Turns out these preferences have price elasticity of demand equal to unity for future consumption, so expenditure on current consumption isn't changing at all, and savings therefore is not affected. What is affected is that future consumption is increasing. So now we're going to briefly look at the general case where he has income in both periods. His consumption is greater, his current consumption is greater than his current income. So this consumer is borrowing this difference, 524 minus 300. So this consumer is a borrower. Let's raise the interest rate as we've been doing and see what happens. So let's make it about a little bit more here. And still a little bit more. Okay. The budget line rotates through this blue point, is now steeper. This is just like it's an increase in the price of current consumption for this consumer. So the consumer buys less current consumption. Finally, I have flat income in both periods. I'm going to raise the rate of time preference parameter, and look what happens. He consumes more in the current period because as his impatience goes up, that's what he does, more in the current period.